I'm Anil Kumar, and in this video we'll understand that the piecewise functions could be continuous or could be discontinuous. So let me take an example. Let us say we have a piecewise function f of x is equal to, I'll take a similar example which we have taken in one of our videos, and there it was a discontinuous function, and now we will see how to make such a function continuous, right? So let us say we have f of x equals to x squared minus 1 when x is less than equal to 1, and it is equals to x plus k when x is greater than 1. So in this particular example we have combination of two functions. One of them is a parabola, so this one you see is a parabola kind of like this, right? So that's the parabola. Now the other one, because it is less than equal to 1, so it's like this, and the other one is a straight line which is k plus x, right? So we don't know what the value of k is, so it's kind of a straight line. So that is the other function. Now these two functions, when you place them on the coordinate plane, right? So let us say we have these two functions here. Then we are sure how to sketch this one, which is x squared minus 1. It should look like kind of like this, right? So it should look like this, right? That's a parabola. X squared, parabola moved 1 unit down, so this is minus 1. If I write x equals to 1, you get 0. Even for minus 1, you get 0. So the two intercepts, x-intercepts, are at plus minus 1. Now this function, which is x plus k on the right side of 1. So that means it could start anywhere, right? So if I write k as 0, then starts at 1, correct? So it could start anywhere. So any line which is kind of like this could be a function representing x plus k. You get the idea, right? Now this point is based on k, correct? So the question for you is, for what value of k can f of x be a continuous function? So that is the question which you need to work on, right? So for what value of k can the given piecewise function be continuous? So now, as you can see, x squared minus 1 is a parabola which is continuous. X plus k is a line which is continuous. So the only point where they are discontinuous are at x equals to 1, right? So to make them continuous, important thing is that the function should have same value at 1, right? So both pieces. So we need to join, basically the idea is we need to join two functions at x equals to 1, right? Then only they can form a continuous function. Is that okay? So if this hole overlaps this filled in place, then it becomes a continuous. This kind of a function will actually be continuous, and that can be done if we equate these two values at 1 to be same, right? So what we are trying to say is that these two pieces, which is x squared minus 1, should be equal to x plus k at x equals to 1. This is what we're trying to figure out, correct? So let's substitute 1 here and find the value of k. So if I substitute 1, we get 1 minus 1. This, let me write 1 plus k. So that is 0 equals to 1 plus k. So k for us is equals to minus 1. So these calculations clearly show that a function which will be continuous will have k as equal to 1. So our answer is, for k equals to 1, f of x is continuous, right? So that is the result. So our function, which is the continuous function, will be f of x equals to x squared minus 1, x plus 1. So if I draw this x plus 1 that will be the line which I have shown here in blue, right? So that is how you can at times make piecewise functions continuous also. For any other value of k, if k is not equal to 1, the function is discontinuous, and the type of discontinuity here is jump discontinuity. So in the coming videos, we'll consider different kinds of discontinuities which could be possible in piecewise functions, and we'll also take a few examples where we need to find such values of k which can make the functions continuous. I hope that will be interesting. I'm Anil Kumar, and I hope you learn from my videos. Thank you and all the best.